Hello friends, today I will solve a LeetCode medium problem that is asked in bi-weekly contest 133. So the problem is minimum operations to make binary array elements equal to 1. So we are given a binary array nums. We can do the following operation on the array any number of times. That is, choose any index I from the array and flip all the elements from index I to the end of the array. So here flipping an element means changing its value from 0 to 1 and from 1 to 0. So we need to return the minimum number of operations required to make all elements in nums equal to 1. So here we are given a binary array nums, and at any instance we can choose any index I from the array and flip all the elements from index I to the end of the array. So we need to return the minimum number of operations required to make all elements in nums equal to 1. So let's understand this problem with the given example. So here I have considered the first example. So the brute force approach will be I'll start from index I equal to 0. So here the value is 0. So I will flip all the elements from index 0 till index 4. So this one will become 0, this 0 becomes 1, and this one becomes 0. So now I'll maintain a result variable called flip count that is initialized to 0. As I have considered a flip, so I'll increment to 1. Now I'll go to next index, that is I equal to 1. So here the value is 0. So I'll flip all elements from index 1 till index 4. So this 0 becomes 1, this 0 becomes 1, this one becomes 0, and this 0 becomes 1. And I'll increment the flip count by 1. So the flip count becomes 2. Now I'll go to next index, that is I equal to 2. Here the value is already 1, so no flip required. Next I'll go to next index, that is I equal to 3. Here the value is 0, so I'll flip all elements from index 3 to 4. So this 0 becomes 1 and this one becomes 0, and I'll increment the flip count to 3. Now at index I equal to 4, the value is 0, so I'll flip this element to 1 and I'll increment the flip count by 1. Now the flip count becomes 4. Now I have reached the end of the array, so I will stop. So we need to flip 4 times to make all entries in the nums array equal to 1. So here if nums of I is 0, so this step is upper bounded by big O of n. So the time complexity will be big O of n square. So this is not optimal. So now let's discuss the idea for optimal approach. So instead of flipping all elements from index I to index n minus 1 if nums of 5 is 0, I'll maintain a variable called flip count. So here I'll maintain a variable called flip count that is initialized to 0. So I'll start traversing from the first element, that is I equal to 0. So here I can see at I equal to 0 the flip count is 0. So at any index, flip count value tells that this many elements before this index has been flipped, At I equal to 0, the flip count is 0. So now I need to flip all values from index 0 to index 4. So instead of flipping all values, I'll flip the value at index 0 to 1 and I'll increment the flip count to 1. So here there is a flip. Now I'll go to next index, that is I equal to 1. So here the current flip count is 1. So it means one element before this index has been flipped. So we need to update the value, that is I'll update to nums of I, that is the current value, plus flip count, that is this many number of times the current value would have been flipped, mod 2, that is as the array should be binary, so I will take mod 2. So the value becomes 1 plus 1 mod 2, that is 0. As the current value is 0, so instead of flipping from index 1 to 4, I will just flip the current element and I will increment the flip count to 2. So here there is a flip. Now I will go to next index, that is I equal to 2. Here the value is 1, the current value, and the flip count is 2. So it means two elements has been flipped before. So I need to update the current value to 1 plus 2 mod 2, that is 1. So the current value will remain same and it's 1. So we don't need to flip the current element. So there will be no flip. Now I'll go to next index, that is I equal to 3. So here the value is 0 and the flip count is 2. So I'll update the current value to 0. So I need to flip all the elements from index 3 to index 4. So instead I'll flip the current element to 1 and I'll increment the flip count by 1. Here is a flip. Now I'll go to next index, that is I equal to 4. Here the value is 1 plus the flip count is 3. So the updated value becomes 0. So here I need to flip this value. So now I'll increment the flip count by 1. Now I will stop because I have reached the end of the array. So this flip count contains the number of flips required. So here the time complexity is big O of n and space is big O of 1, because we are just declaring only one variable, so the space will be constant. So now I'll code the solution. First I'll declare a variable called flip count, that is initialized to 0. So now I'll run a for loop from int I equal to 0, I less than nums length I plus plus. So here I'll first update nums of I, that is equal to the current value nums of I plus flip count mod 2. So if nums of I equal to 0, I'll update nums of I to 1, then I'll increment the flip count. At the end I'll return the flip count. So let's run it for the sample test cases. Sample test cases are running fine. Now I'll submit it. So it's working as expected. So let's discuss the time and space complexity. So here I am linearly traversing the nums array, and in each iteration I am doing some constant number of operations. So the time complexity will be big O of n, and as I am declaring only one extra variable, so the space complexity will be big O of 1. I have attached the GitHub link for this solution in the comment. Please do check it out. If you like this video, please subscribe. And if you have any doubts or suggestions, please post it in the comments. I'll be happy to help. Thank you.